curve. And we can turn this into a sine function. The sine curve that we have, so if we have a look here, we've got y equals 1 sine 1x plus 0. Okay, so it's not the best notation. We would write that as y equals sine x or y equals sine theta. That is our standard curve. Okay, so when our angle equals 0, sine theta equals 0. As we increase the point P, sine curve goes up until we get to a point P at 90 degrees. It's maxed out at 1, and then it starts to come down. Now we're at point P is 180, maxed out as low as it'll go, so minimized at minus 1 when it's 270 degrees, and then back to 0 at 360 degrees. The scale on the x-axis in this is in radians, which makes it problematic to sort of view, but this here you just need to think 0, 90, 180, 270, 360. So this one would be, well, this one just off the screen is 540, etc., etc. Okay, so this is a periodic function. It repeats over and over, okay? And if we want to create a model, we can change certain things. So here I've created 3 sliders. So A, B, and C. What they're going to do is they're going to change the values of these. I just want you to observe what they do. We're going to be discussing this later. Okay, so first one I'm going to change is C. C is the easiest one to see what happens. Okay, so on my slider, if I move C to the right, so you'll notice that the graph is lifting up. So C is now 1, and that's where it cuts the y-axis. So if we continue to increase it, you can see that it's going up. It now crosses at 2. If we move it the other way, we can move it down. So, and then we can go negative as well. So we can move the sine curve below. So as with our straight lines, C is where the sine curve crosses the y-axis. Okay, A is also quite easy-ish to spot. So what I'll do is I'll start to make it bigger, and what you should hopefully see is now, before the sine curve started at 0, 0, and at 90 it was at 1, but now it's now at 2. At 180 it's still 0, at 270 it was 1, it's now at 2, at 360 it was 0, and it's still 0. So we haven't done anything apart from stretched it going up. Okay, so if I continue to increase this, when we get to 3, you should see that this point has now raised to 3. So sine of 90 is 3 when we've got y equals 3 sine x plus 0. Okay, likewise, the interesting question is what happens at 0. So we can make it really squidgy, and at 0 we're going to get a straight line. Why do we get a straight line? Because we've got y equals 0 times sine x plus 0, so we get the x-axis. What happens when we make it negative? Well, it comes back, but this time, so let's go to negative 1. This time 90 should be 1, but it's a reflection in the x-axis. Okay, so we've done this with our transformation unit. Right, so we'll label that shortly. B is where it gets a little bit harder to see. So B is going to change this value in front of the x. So I'll leave A as 1, C as 0, so we can try and see what's happening. Okay, so I'll stop here and have a look at what's happening. So here, this point is 0, 0, so that hasn't changed. This point was at 90. Okay, 90 is actually here. So this point is 90, and this point is 180. So this sine curve, which was all the way over here, is now sort of squished up. And if we look here, so that's 1 sine, and then whoop, there's a second sine curve that would normally have been, so if you keep an eye on this point, 6 point something, 6.2ish. If I move that back to 1, so 0, 6.2, we can see that it happens once, yeah? But if we move that to 2, we now have 1, 2 times in that thing. If we move it to 3, we've now got 1, 2, 3. And if we reduce that, and so we can make it really long and thin. So half. So this happens half a time in one complete rotation. So the sine happens half. 0 it doesn't, and then at negative we then start to say how many times does it happen? Well, it happens -1 times. Yeah, it happens not twice at -2. So we're going to define what A, B, and C are as we move into this modeling. Okay.